if somebody doesn't believe Tesla's going to solve autonomy, I think they should not be an investor in the company. But we will, and we are.
As you probably know, I'm not one to cover earnings reports. Lots of numbers, typically pretty boring, but this latest one had so much juicy info about the future of full self-driving that I have to make this video. Let's start with this teaser of their future ride-hailing app. Many people have said this is just a render and probably not how it's actually going to look, but I don't ever recall a time Tesla released something that didn't look just like the prototype, so I think these are worth taking a closer look at. It looks like you'll be able to order a car by holding the summon button, which includes the estimated wait time at the bottom of the screen. The next shot shows a really cool 3D map of the location of the car and when it'll be arriving. In the next one, we see interior climate controls, which you can probably set even before the car picks you up, which is super cool. Also pretty interesting that it shows 4 occupants max for a Model Y, which probably means people won't be allowed to sit in the driver's seat. And the last shot shows the car's path, media and climate controls, estimated time of arrival, and everything else you'll need for your ride. Here we see the total amount of miles FSD has driven, and you might notice the gigantic spike at the end with the release of version 12. Takeaways from this graph is that it took Tesla 3 years to get to the first billion miles on full self-driving, but at this current rate of over 10 million miles a day, we could possibly see the next billion in just a few months. Absolutely incredible. And this might be the most important graph on the entire slide, which is Tesla's training capacity for making new versions of full self-driving, because the bottleneck has always been compute and not data. Elon mentioned they'd be around 85,000 H100s by the end of the year, so expect this graph to get even more steep. And here we have our first real look at the Dojo training cluster, and yes, believe it or not, this is an actual image and not a render. I remember them talking about this years ago at the first AI day, and it's crazy to see it in real life. I think all this new training capacity means we're going to see FSD progress at a rate that almost nobody is expecting. Elon mentioned during the call that they know how capable future versions are 3 or 4 months in advance, which is why I think they're so confident about the robotaxi unveil and are already developing mock-ups for their ride-hailing app. Also interesting that this means the version we're on now, which is 12.3, was probably made while Tesla was still compute restrained. Elon responded to a video clip I posted on X of the car failing a pretty simple scenario, saying that 12.4 is a major improvement and 12.5 is on a completely different level. Usually I'm pretty skeptical of Elon statements like these, but experiencing the rapid progress firsthand, I gotta say, I think it's for real this time. The next few months are going to be an insane time for full self-driving. The last highlight I want to mention is that someone asked about FSD licensing, and Elon said there was one major auto manufacturer that is already in talks with them, but we have no idea which one. Ford. Sorry, something caught in my throat there. Anyways, the remainder of this video is going to be a chopped up version of the earnings call, focusing on everything said about full self-driving. I skipped over a lot of things in this video, and if you're even the tiniest bit curious about this stuff, I highly recommend listening. It also took me a lot more time than I care to admit to chop up the silent parts and add subtitles, so if you appreciate it, please consider leaving a like.
Regarding FSD version 12, which is the pure AI-based self-driving, people that if you haven't experienced this, I strongly urge you to try it out. It's profound, and the rate of improvement is rapid. So we've now turned that on for all cars with the cameras and inference computer and everything from hardware 3 on in North America. So it's been pushed out to I think around 1.8 million vehicles, and we're seeing about half of people use it so far, and that percentage is increasing with each passing week. So we now have over 300 billion miles that have been driven with FSD V12. Since the launch of full self-driving, supervised full self-driving, it's become very clear that the vision-based approach with end-to-end neural networks is the right solution for scalable autonomy. And it's really how humans drive. Our entire road network is designed for biological neural nets and eyes. So naturally, cameras and digital neural nets are the solution to our current road system. To make it more accessible, we've reduced the subscription price to $99 a month, so it's easy to try out. And as we've announced, we'll be showcasing our purpose-built robotaxi or cybercab in August. Yeah. Regarding AI compute, Over the past few months, we've been actively working on expanding Tesla's core AI infrastructure. For a while there, we were training constrained in our progress. We are, at this point, no longer training constrained, and so we're making rapid progress. We've installed and commissioned, meaning they're actually working, 35,000 H100 computers, or GPUs. GPU is the wrong word. They need a new word. I always feel like a wince when I say GPU, because it's not GPU stands for graphics and doesn't do graphics. But anyway, roughly 35,000 H100s are active, and we expect that to be probably 85,000 or thereabouts by the end of this year in training, just for training. We are making sure that we're being as efficient as possible in our training. It's not just about the number of H100s, but how efficiently they're used. So in conclusion, we're super excited about our autonomy roadmap. I think it should be obvious to anyone who's driving version 12 in a Tesla that it is only a matter of time before we exceed the reliability of humans, and not much time at that. And we're really headed for an electric vehicle, an autonomous future. And I'll go back to something I said several years ago, that in the future, gasoline cars that are not autonomous will be like riding a horse and using a flip phone. And that will become very obvious in hindsight.
The third question is, what is Tesla's current assessment of the pathway towards regulatory approval for unsupervised FSD in the US? And how should we think about the appropriate safety threshold compared to human drivers?
Sure. I can start. There are a handful of states that already have adopted autonomous vehicle laws. These states are paving the way for operations, while the data for such operations guides a broader adoption of driverless vehicles. I think Ashok can talk a little bit about our safety methodology, but we expect that these states and the work ongoing, as well as the data that we're providing, will pave the way for a broad-based regulatory approval in the US at least, and then other countries as well.
Yeah. It's actually been pretty helpful that other autonomous car companies have been cutting a path through the regulatory jungle. That's actually quite helpful. And they have obviously been operating in San Francisco for a while. I think they got approval for City of LA. So these approvals are happening rapidly. I think if you've got at scale a statistically significant amount of data that shows conclusively that the autonomous car has, let's say, half the accident rate of a human-driven car, I think that's difficult to ignore, because at that point, stopping autonomy means killing people. So I actually do not think that there will be significant regulatory barriers, provided there is conclusive data that the autonomous car is safer than a human-driven car. And in my view, this will be much like elevators. Yeah, elevators used to be operated by a guy with a relay switch, but sometimes that guy would get tired or drunk or just make a mistake and shear somebody in half between floors. So now we just get in an elevator and press a button. We don't think about it. In fact, it's kind of weird if somebody's standing there with a relay switch. That'll be how cars work. You just summon a car using your phone. You get in, it takes you to a destination, you get out.
You don't even think about it.
You don't even think about it. Just like an elevator. It takes you to your floor. That's it. Don't think about how the elevator is working or anything like that. Now, something I should clarify is that Tesla will be operating the fleet. So you can think of like how Tesla like, I don't know, some combination of Airbnb and Uber, meaning that there'll be some number of cars that Tesla owns itself and operates in the fleet. There'll be some number of cars, and then there'll be a bunch of cars where they're owned by the end user, but that end user can add or subtract their car to the fleet whenever they want. And they can decide if they want to only let the car be used by friends and family, or only by 5-star users, or by anyone. And at any time, they could have the car come back to them and be exclusively theirs, like an Airbnb. You could rent out your guest room or not anytime you want. So as our fleet grows, we have 7 million cars, 9 million cars, eventually tens of millions of cars worldwide, with a constant feedback loop. Every time something goes wrong, that gets added to the training data, and you get this training flywheel happening in the same way that Google search has the sort of flywheel. It's very difficult to compete with Google because people are constantly doing searches and clicking, and Google's getting that feedback loop. It's the same with Tesla, but at a scale that is maybe difficult to comprehend, but ultimately be tens of millions. I think there's also some potential here for an AWS element down the road, where if we've got very powerful inference, because we've got a hardware 3 in the cars, but now all cars are being made with hardware 4. Hardware 5 is pretty much designed and should be in cars hopefully towards the end of next year. And there's a potential to have to run when the car is not moving to actually run distributed inference. So kind of like AWS, but distributed inference. Like, it takes a lot of computers to train an AI model, but many orders of magnitude less compute to run it. So if you can imagine a future perhaps where there's a fleet of 100 million Teslas, and on average they've got like maybe a kilowatt of inference compute, that's 100 gigawatts of inference compute distributed all around the world. It's pretty hard to put together 100 gigawatts of AI compute. And even in an autonomous future where the car is perhaps used, instead of being used 10 hours a week, is used 50 hours a week, that still leaves over 100 hours a week where the car inference computer could be doing something else. And it seems like it would be a waste not to use it.
Asher, do you want to chime in on peer process and safety?
Yeah, we have like multiple tiers of validating the safety. For like in any given week, we train hundreds of neural networks that can produce different trajectories for how to drive the car. We replay them through the millions of clips that we have already collected from our users and our own QA. Those are like critical events, like someone jumping out in front, or like other critical events that we have gathered a database over many, many years. And we replay through all of them to make sure that we are net improving safety. And on top of it, we have simulation systems that also try to recreate this and test this in closed loop fashion. Once all of this is validated, we give it to our own QA drivers. We have hundreds of them in different cities, in San Francisco, Los Angeles, Austin, New York, a lot of different locations. They are also driving this and collecting real world miles. And we have an estimate of what are the critical events. Are they a net improvement compared to the previous week's builds? And once we have confidence that the build is a net improvement, then we start shipping to early users, like 2,000 employees initially, that they would like get the build. They would give feedback on like if it's an improvement, or are they noticing some new issues that we did not capture in our own QA process. And only after all of this is validated, then we go to external customers. And even when we go external, we have like live dashboards of monitoring every critical event that's happening in the fleet, sorted by the criticality of it. So we are having a constant pulse on the build's quality and the safety improvement along the way. And then any failures, like Elon alluded to, you get the data back, add it to the training, and that improves the model in the next cycle. So we have this like constant feedback loop of issues, fixes, evaluations, and then it rinse and repeat. And especially with the new V2 architecture, all of this is automatically improving without requiring much engineering interventions, in the sense that engineers don't have to be creative in like how they code the algorithms. It's mostly learning on its own based on data. And so you see that, okay, we failed here, or like this is how a person shows, this is how you drive this intersection or something like that. We get the data back, we add it to the neural network, and it learns from that training data automatically, instead of some engineers saying that, oh, here you must rotate the steering wheel by this much or something like that. There's no hard if-else conditions. It's everything is neural network. It's very soft. It's probabilistic. So it will adapt its probability distribution based on the new data that it's getting.
Yeah, and we do have some insight into how good the things will be in, like, let's say 3 or 4 months, because we have advanced models that are far more capable than what is in the car, but have some issues with them that we need to fix. So there'll be a step change improvement in the capabilities of the car, but it'll have some quirks that are that need to be addressed in order to release it. As Ashok was saying, we have to be very careful in what we release to the fleet, or to customers in general. So like if we look at say 12.4 and 12.5, which are really could arguably even be version 13 and version 14, because it's pretty close to a total retrain of the neural nets in each case, or substantially different. So we have good insight into where the where the models, how well the car will perform in say 3 or 4 months.
Yeah. In terms of scaling laws, people in the AI community generally talk about model scaling laws, where they increase the model size a lot, and then they have corresponding gains in performance. But we have also figured out scaling laws and other axes. In addition to the model size scaling, we can also have data scaling. You can increase the amount of data you use to train the neural network, and that also gives similar gains. And you can also scale up by training compute. You can train it for much longer and get on more GPUs or more Dojo nodes, and that also gives better performance. And you can also have architecture scaling, where you come up with better architectures that for the same amount of compute produce better results. So a combination of model size scaling, data scaling, training compute scaling, and the architecture scaling, we can basically if we continue scaling based on this ratio, we can sort of predict future performance. Obviously, it takes time to do the experiments because it takes few weeks to train. It takes a few weeks to collect tens of millions of video clips and process all of them. But you can estimate what's going to be the future progress based on the trends that we have seen in the past, and they've generally held true based on the past data.
But really, the way to think of Tesla is almost entirely in terms of solving autonomy and being able to turn on that autonomy for a gigantic fleet. And I think it might be the biggest asset value appreciation in history when that day happens, when you can do unsupervised full self-driving.
5 million cars.
Yeah,
well, a little less.
Yeah, it'll be 7 million cars, in a year or so.
Yeah,
and then 10 million, and then. Eventually, we're talking about tens of millions of cars. Not eventually, it's like before the end of this decade. Yeah, before the end of the decade, it's several tens of millions of cars, I think. I think, Kathy Wood said it best. Like, really, we should be thought of as an AI or robotics company. If you value Tesla as just like an auto company, you just have the fundamentally, it's just the wrong framework. And it will come to be. If you ask the wrong question, then the right answer is impossible. If somebody doesn't believe Tesla's going to solve autonomy, I think they should not be an investor in the company. Like that is, but we will, and we are. And then you have a car that goes from 10 hours of use a week, like an hour and a half a day, to probably 50, but it costs the same.
I think that's the key thing to remember, right? Especially if you look at FSD supervised. If you didn't believe in autonomy, they should give you a preview that this is coming. It's actually getting better day by day.
Yeah, if you've not tried the FSD 12.3, and like I said, 12.4 is going to be significantly better, and 12.5 even better than that, and we have visibility into those things, then you really don't understand what's going on. It's not possible.
Yeah, and that's why we can't just look at just as a car company, because a car company would just have a car. But here we have more than a car company because the cars can be autonomous. And like I said, it's happening.
Yeah, this is all in addition to Tesla working. The overall AI community is just improving rapidly.
Yeah. We're putting the actual auto in automobile. So, so sort of a lot of we like, well, sort of like tell us about future horse carriages you're making. I'm like, well, actually, it doesn't need a horse. That's the whole point. That's really the whole point.
Okay, thank you. The next question comes from Alex Potter from Piper Sandler. Alex, please go ahead and unmute.
Great, thanks. Yeah, so couldn't agree more. The thesis hinges completely on AI, the future of AI, full self-driving, neural net training, all of these things. In that context, Elon, you've spoken about your desire to obtain 25% voting control of the company. And I understand completely why that would be. So I'm not necessarily asking about that. I'm asking if you've come up with any mechanism by which you can ensure that you'll obtain that level of voting control. Because if not, then the core part of the thesis could potentially be at risk. So any additional commentary you might have on that topic?
Well, I think no matter what, Tesla, even if I got kidnapped by aliens tomorrow, Tesla will solve autonomy, maybe a little slower, but it would solve autonomy for vehicles at least. I don't know if it would win on with respect to Optimus or with respect to future products, but it would. That there's enough momentum for Tesla to solve autonomy, even if I disappeared for vehicles. Now, there's
Okay.
a whole range of things we can do in the future. Beyond that, I'd be more reticent with respect to Optimus. If we have a super sentient humanoid robot that can follow you indoors and that you can't escape, we're talking Terminator level risk, then I'd be uncomfortable with, if there's not some meaningful level of influence over how that is deployed. And, if there's, shareholders have an opportunity to ratify or re-ratify the sort of competition. I guess I can't say that. Whatever, but that is a fact. They have an opportunity.
Okay. Very good.
And we'll see. If the company generates a lot of positive cash flow, we could obviously buy back shares.
The company had previously characterized potential FSD licensing discussions as in the early phase, and some OEMs had not really been believing in it. Can you elaborate on how much the licensing business opportunity you mentioned today has progressed? And is there anything Tesla needs to achieve with the technology in terms of product milestones in order to be successful at reaching a licensing agreement, in your view?
Well, I think it just needs to be obvious that our approach is the right approach. And I think it is. I think we've now with 12.3, if you just have the car drive you around, it is obvious that our solution with a relatively low cost inference computer and standard cameras can achieve self-driving. No LiDARs, no radars, no ultrasonics, nothing.
No heavy integration work for the vehicle manufacturers.
Yeah, it's so it would really just be a case of having them use the same cameras and inference computer and licensing our software. And but it's once it becomes obvious that if you don't have this in a car, nobody wants your car.
Yeah,
It's like it's a smart car. I mean, I just remember back when Nokia was king of the hill. Yeah,
Dominating the cell phone industry.
Yeah, crushing. And then I saw them come out with a smartphone that was basically a brick with limited functionality. And then the iPhone and Android. But people still did not understand that all the phones are going to be that way. There's not going to be any flip phones. There'll be a niche product.
Or home phones.
Yeah, not even exactly. When was the last time you saw a home phone? Yeah,
I have no idea. In a hotel. Sometimes in a hotel.
Yeah, the hotels have them. Yeah. So the people don't understand all cars will need to be smart cars. Or you will not sell the car will not, nobody will buy it. Once that becomes obvious, I think licensing becomes not optional.
Becomes a method of survival.
Yeah, so it's license it or nobody will buy your car.
I mean, one other thing which I'll add is in the conversations which we've had with some of these OEMs, I just want to also point out that they take a lot of time in their product life cycle.
Yeah.
They're talking about years before they will, put it in their product. We might have a licensing deal earlier than that, but it takes a while. So this is where the big difference between us and them is.
Yeah, I mean, really, a deal signed now would result in it being in a car in probably 3 years.
That would be early.
Yeah, that's like lightning, basically. So
that's being an eager OEM.
Yeah. So, I mean, I wouldn't be surprised if we do sign a deal. I think we're good chance we do sign a deal this year, maybe more than one. But yeah, it would be probably 3 years before it's integrated with a car, even though all you need is cameras and our inference computer. So it's like not a massive design change.
Yeah, and again, just to clarify, it's not the work which we have to do, it's the work which they have to do.
First, could you please help us understand maybe some of the timing of launching FSD in additional geographies, including maybe clarifying your recent comment about China? Thank you.
I mean, like new markets? Yeah, there are a bunch of markets where we don't currently sell cars that we should be selling cars in. We'll see some acceleration of that.
And FSD in new markets?
Yeah. So the thing about the end-to-end neural net based autonomy is that just like a human, it actually works pretty well without modification in almost any market. So we plan on, with the approval of the regulators, releasing it as a supervised autonomy system in any market where we can get regulatory approval for that, which we think includes China. So, yeah, it's just like a human, you can go rent a car in a foreign country and you can drive pretty well. Obviously, if you live in that country, you'll drive better, and so we'll make the car drive better in these other countries with country-specific training. but it can drive quite well almost everywhere.
The basics of driving are basically the same everywhere. Like, car is a car, traffic light is a traffic light, road is the road. It's like,
Yeah. It understands that it shouldn't hit things no matter where it is.
Exactly. There are some road rules that you need to follow. In China, you shouldn't cross over a solid line to do a lane change. US is a recommendation, I think. China, you get fined heavily if you do that. We have to do some adaptations, but it's mostly smaller adaptations, not like an entire change of stack or something like that.
Yeah.
Given the pursuit of Tesla really as a leader in AI for the physical world, and your comments around distributed inference, can you talk about what that approach is unlocking beyond what's happening in the vehicle right now?
So, do you want to say something?
Yeah, I can mention like the car, even when it's a full robotaxi, it's probably going to be used around 50 hours a week.
That's my guess. Like a third of the hours of the week.
Yeah. It could be more or less, but then there's certainly going to be some hours left for charging and cleaning and maintenance. In that world, it can do a lot of other workloads. Even right now, we are seeing, for example, these LLM companies have this like batch workloads where they send a bunch of documents, and those are run through pretty large neural networks. It take a lot of compute to chunk through those workloads. And now that we have already paid for this compute in these cars, it might be wise to use them and not let them be idle, be like buying a lot of expensive machinery and letting them be idle. Like, we don't want that. We'd want to use the compute as much as possible and close to like basically 100% of the time, make effective use of it.
That's why I think it's analogous to Amazon Web Services, where people didn't expect that AWS would be the most valuable part of Amazon when it started out as a bookstore. So that was on nobody's radar. But they found that they had excess compute because the compute needs would spike to extreme levels for brief periods of the year, and then they had idle compute for the rest of the year. So then what should they do with all that excess compute for the rest of the year? That's kind of...
Monetize it.
Yeah, monetize it. So it seems like kind of a no-brainer to say, okay, if we've got millions and then tens of millions of vehicles out there where the computers are idle most of the time, that we might as well have them do something useful.
Yeah, exactly.
And then, I mean, if you get like to the 100 million vehicle level, which I think we will at some point get to, then, and you've got a kilowatt of usable compute, and maybe you're on hardware 6 or 7 by that time, then you really, I think you'd have on the order of 100 gigawatts of usable compute, which might be more than any company, probably more than any company.
Yeah, probably. Because it takes a lot of intelligence to drive the car anyway. And when it's not driving the car, you just put this intelligence to other uses, just solving scientific problems.
Just like a human.
Or answering dumb questions for someone else.
We've already learned a lot of deploying workloads to these compute nodes.
Yeah. And unlike laptops and our cell phones, it is totally under Tesla's control. So it's easier to distribute the workload across different nodes as opposed to, asking users for permission on their own cell phones would be very tedious.
Well, you just drain the battery on them.
Yeah, exactly. The battery is also limited.
So technically, I suppose like Apple would have the most amount of distributed compute, but you can't use it because you can't get you can't just run the phone at full power and drain the battery.
Yep.
So whereas for the car, even if you're a kilowatt level inference computer, which is crazy power compared to a phone, if you've got a 50 or 60 kilowatt hour pack, it's still not a big deal to run.
If you're plugged in.
Whether you're plugged in or not, it could be plugged in or not plugged in. You could run for 10 hours and use 10 kilowatt hours of your kilowatt of compute.
Forever.
Yeah.
Already got a built-in liquid cooled thermal management.
Yeah, it's exactly
expense for data centers. So.
Exactly. So it's distributed power generation, distributed access to power, and distributed cooling. And it's already paid for.
Yeah, I mean, that distributed power and cooling, people underestimate that costs a lot of money.
Really big deal.
Yeah, it does.
Yeah, and the capex is shared by the entire world.
Yes.
Sort of everyone owns a small chunk, and they get a small profit out of it, maybe.
Yeah. I once again would just like to strongly recommend that anyone who is, I guess, thinking about the Tesla stock should really drive FSD 12.3. You can't, it's impossible to understand the company if you do not do this.